Hello guys, welcome back to the Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today our lecture is about the reinforcement in the cantilever beam. This lecture is mainly focused on the behavior of the cantilever beam, that how it behaves different from the simply supported beam. You can see here there is a simply supported beam where it is two supports. One on the left end is the hinge support and one on the right end is the roller support. While case on the cantilever beam, it is always one fixed support at one end. You can see here is a fixed support provided at one end of the beam, while the other end of the beam is always in hanging position. So this is the cantilever beam, but their deflection and their reinforcement behavior is different from the simply supported beam. I will explain in detail now. Let's consider this is the simply supported beam, and this beam has been loaded by uniformly distributed load. So upon loading, this beam will show deflection in this way. So you can see here that the upper portion of the beam has been contracted, or we can say the beam has been compressed on the upside, while on the downside you can see the length has been increased of the beam, and this portion of the beam has been tensioned. This is in tension, while the upper portion of the beam has been compressed. So we have tension at the bottom of the beam and we have compression at the top of the beam. So we know that the concrete is weak in tension, so to avoid this tensile failure of the beam, we provide reinforcement at the bottom portion of the beam here, because we have tension at the bottom portion, while concrete is strong in compression, so there is no need to provide the steel bar at the top of the beam. As I draw the cross section of this beam, so I have to provide the reinforcement at the bottom of the beam, because this reinforcement will help in taking the tensile load, because concrete is weak in tension. So this steel bar will help to take the tension load. But in case of the cantilever beam, the behavior is opposite. As I place the uniformly distributed load here on the cantilever beam, it will deflect in this way. In which the bottom portion has been compressed. This portion has been compression, while this top portion has been in tension. It has been increased in length. So what we say that the tension has been created in the top portion of the cantilever beam. So we see here that the tension is in the upside of the beam. It is not like the simply supported beam where we have tension in the bottom of the beam. But in this case, due to the application and due to this fixed end, this beam will deflect in this way. So we have tension here at the top of the beam, and we have compression at the bottom of the beam. Compression and tension at the top of the beam. So now to avoid the tensile failure, we have to provide the reinforcement. So in case of the cantilever beam, we have to provide the reinforcement in top of the section. So if I draw the cross section of the beam, cantilever beam, I have to provide the reinforcement at the top of the beam, because the tensile forces are now acting at the top of the cantilever beam due to its fixed end. The one end is fixed and the other is free. So due to this behavior, it will show tension in the top of the beam. So that's why we try to provide the reinforcement at the top of the beam. While in case of the simply supported beam, it is always in the bottom of the beam. This was the main difference, that why we provide the reinforcement in cantilever beam at the top of the beam, because we have tension in the top of the beam. While in case of the simply supported beam, we always provide the reinforcement at the bottom of the beam, because the tensile forces are acting at the bottom, while here the compression forces are acting at the bottom, and concrete is enough to take these compressive forces. Hope you guys understand, and subscribe my channel for daily civil engineering videos. Thank you for watching my video.